Your doctor just prescribed you a statin. Now, do you really need to be on one? This is a question that I get asked all the time by our clients. So today I want to explain to you exactly what a statin is, how it works, and why your doctor may have prescribed this for you. So the first thing before I get started, I want you to make sure, what is a statin? Why do they even call these statins? Statins are drugs that your doctor will prescribe for you that is supposed to lower your LDL cholesterol level out of your blood. The reason they call it a statin is because there are several different medications that are in the statin family, and the generic name all ends in statin. So like Lipitor is a torvastatin, Zocor is simvastatin, Pravachol is pravastatin. You understand what's going on? So it's the generic name, they all end in statin. So that's just why they call it a statin. But what is a statin actually? A statin actually is a 3-hydroxy, 3-methylglutaril, coenzyme A reductase inhibitor. Now, I know that's a mouthful. To shorten it, they're just called HMG CoA reductase inhibitors. But I'm going to explain exactly what that means so you don't have to worry about that. I'll explain exactly how these things work. And again, what's the purpose of a statin? It's supposed to lower your blood LDL level. That's the purpose of it. So first, the big question you have to ask is, are high LDLs bad? That's not a yes or no question. The problem is with the way the pharmaceutical companies have trained our doctors is that LDL is all you have to look at on a cholesterol panel. If they have a high LDL, you put them on statins. That is not right, and that should not be happening, because the fact is there's two different types of LDLs. There's a large buoyant LDL, which is perfectly normal, the way God made us from the beginning. But then there are these very small, dense LDLs, and that is what we're truly concerned of. But the problem is, here, what they do, all the medical system, they combine all these LDLs together and they just report it out as one big problem. And that is wrong. So I want to make sure you totally understand what's going on. So first, with the good LDLs, with the way our bodies normally work, our livers are what's responsible for turning all the fructose that we eat. Fructose is what's in fruit, and it's also what's in sugar and high fructose corn syrup. Our bodies don't know what to do with fructose. Every single cell in our body knows what to do with the glucose portion of sugar and high fructose corn syrup. But as far as how it's going to handle this fructose, other cells in our bodies can't do it. So it has to go straight to our liver. And for the majority, almost all the fructose that we eat that goes to our liver, it gets turned straight into a form of fat called triglycerides. Think about how a bear hibernates. It scavenges all the berries because they're trying to get as much fructose as possible. It all gets turned into fat, and that's what fattens the bear up so they can go and they can hibernate. So that just reminds you, fructose is equal to fat. When you eat fructose, your liver turned it into triglycerides. Now, the other portion of sugar and high fructose corn syrup, because sugar, remember, is a 50-50. It's 50% glucose and 50% fructose. High fructose corn syrup is the exact same thing, only it's only 45% glucose and 55% fructose, which means it's 55% more of the stuff that actually causes obesity and causes triglycerides and then fat. So fructose, we just talked about that. Glucose. Every single cell in our body knows how to use glucose for an energy source. It's only supposed to be using it for fight or flight, but at least our body knows what to do with this chemical of carbohydrates called glucose. And glucose, remember, carbohydrates and glucose are saying the exact same thing. If you have 50 grams of carbohydrates, that means you have 50 grams of glucose. And glucose also gets turned straight into fat. A little bit of it can be used for energy, but usually we don't burn off that much energy. So most of it gets turned into fat. And the way it does it is we eat anything that has glucose in it. So any carbohydrate, which means anything from a plant or anything that's made from a laboratory, all this man-made food in box, bottle, bag, and can, they all contain glucose and fructose. So when we eat all this glucose, our blood raises insulin, and our insulin tells our liver, turn all that excess glucose that you just ate, turn that into fat in the form of triglycerides. So that's what happens. Our livers turn all the fructose into triglycerides and all the excess glucose into triglycerides. Our liver also produces 80% of all the cholesterol that our body needs. Because as I go through this, you'll realize cholesterol is not bad. Cholesterol is vital to life. We have to have it or we would die. So cholesterol is not this bad, evil villain that the drug companies are trying to teach the physicians that it is. So what happens is our liver is making all these triglycerides, which is a form of fat, and making all this cholesterol. It needs to get that out of our liver and transport that around to all the sites in our body that need fat and cholesterol. And that is every single cell in our body. So the way it does it is it puts it in a little, I call them fat mobiles. They're just little lipoproteins. So think of it like a shrinkable ship. So when it first starts off and the liver says, okay, I've got to get my cholesterol and my triglycerides out of here. And it can't just throw this fat into the bloodstream because your bloodstream is mainly water. And so fat and water doesn't mix. So it puts this protein around this fat and cholesterol. So the fat and cholesterol is like in the cargo of this ship. And it puts a little bit of cholesterol and a whole bunch of triglycerides in the hull of this ship. And that's called a very low density lipoprotein. Okay, it's a VLDL. When you get your cholesterol panel, that's what a VLDL is. And it's called very low density because it has a lot of fat and a lot of cholesterol. So it floats up on top of the water, just like fat floats. So it's called a very low density lipoprotein. Now, your liver sends this very low density lipoprotein, this VLDL, out into the bloodstream to go around and circulate and give all this fat and cholesterol to all the different cells in your body that needs it. As it does, it starts to shrink. So it's giving away its cargo, and this fat mobile can shrink. So it goes from a very low density lipoprotein, VLDL, to an intermediate density lipoprotein called an IDL. Then it continues to travel around and gives up more triglycerides and cholesterol, and it shrinks even more and becomes an LDL, a low density lipoprotein. Now, once this happens, that LDL, after it gives away some more of the triglycerides and a little bit of cholesterol, that comes back to the liver, attaches to a receptor on the liver. The liver brings that LDL back in, stuffs it full of more cholesterol and triglycerides, makes it swell up to be a VLDL again, and then sends it back on its rounds. That is perfectly normal. These LDLs are the large, buoyant ones. There's no trouble with those whatsoever. That's the way God made us, because we have to transfer all this fat and cholesterol around our bodies because it's so important for us to have. So where do the bad LDLs come from? These bad LDLs goes through that exact same process, except when you eat a ton of fructose and a ton of glucose, like most people do every single day, all throughout the day, because that's what the laboratory food puts in all their food to keep you hungry. So every 2 to 3 hours, you're always eating more of their toxic sludge. And all of it is made out of glucose, fructose, seed oils, which are horribly inflammatory, and chemicals, which are also inflammatory. So the laboratory food in the box, bottle, bag, and can that lines all the center aisles of our grocery stores that are made in a lab, not out in a pasture, not in a nice green field that's growing fruits and vegetables and pastures that are raising live animals. It's made in a lab. And this is what is killing us. So now we're eating all this glucose and all this fructose all through the day. Our body does not use that. So it goes to the liver, and our liver starts producing these VLDLs, turns out all that glucose, fructose, and triglycerides. But since we eat so much, it has to put a little bit less cholesterol in these VLDLs and a lot more of these triglycerides because we're constantly producing them. So now we send this VLDL out that's just loaded with all these triglycerides we keep making from this food. So now as the VLDL goes around, starts giving away the triglycerides, and then turns to IDL, and then turns into an LDL as it keeps shrinking, what happens is it started off with a little bit less cholesterol and more triglycerides. So now when it shrinks down to an LDL and starts giving away more triglycerides, it shrinks down to even smaller. It's a very small, dense LDL because it started with more triglycerides. So now as it shrinks down, gets rid of the triglycerides, it's very dense. It's mostly cholesterol that's in this small, dense LDL. The problem with that is instead of just having a regular large point LDL, it turns into the small dense LDL. The small dense LDL, when it comes back to the liver to hook on so it can be taken back to the liver and turned back into VLDL, the small dense LDL, it's too small. It doesn't fit that receptor anymore. So where a normal LDL will stay out in the bloodstream for about 48 hours, this small dense LDL that can't bind to the liver to be able to be taken back up, it stays out for about twice as long. Now, the problem with that is first, you have a small dense LDL that's floating around in your bloodstream. It stays in your bloodstream twice as long as a large buoyant LDL. By this happening, it's being made because you have high blood glucose, and glucose is what's being turned into these triglycerides. High glucose is very bad for your body because glucose attaches to proteins, and your whole body's made out of protein. Anything you touch, your muscles, your organs, your skin, some of your hormones, every single thing that you touch, your vital organs, these are all made out of protein, and high glucose attaches to these proteins and it ruins it. It's called glycation. Glucose glycates the proteins of your body, including in your blood vessels, and this damages those proteins. The other thing that happens is when you're eating all this stuff, also, you're probably eating it from this lab-made food that has a ton of chemicals and seed oils that are extremely inflammatory to your body. So now you have all this inflammation in your body, and these small, dense LDLs become inflamed. So now you have a small, dense LDL. It's much smaller. It's glycated. It's inflamed. And the next thing that happens is it becomes oxidized, because whenever you use glucose for your energy source, the byproducts are carbon dioxide and water, and then these free radicals called reactive oxygen species. That's just a little bitty oxygen that's floating around trying to find something that it can attach to. And that's why everybody is talking about having antioxidants on board now, that you need to take antioxidants like vitamin C, because that takes care of these little free radicals, these oxygen species. But again, if you're using fat for your energy source, you don't need to worry about these little free radicals as much. So now, going back, now we have a small dense LDL. It's staying out in the bloodstream for twice as long because it can't be retaken up into the liver. Now the small dense LDL becomes glycated, inflamed, and oxidized. When that happens, this small dense LDL gets attached to your blood vessels and it buries its way into the blood vessels. And now your body sees this as an intruder in your blood vessels, and it tries to get rid of it. It sends down its white blood cells to try to release it and eat it up like a little Pac-Man. But as it does, and as you continue to make these small dense LDLs, you cause more and more of this arterial damage, and your white blood cells are trying to take care of it. But actually, by taking care of it with these enzymes, it actually ends up causing more damage to your blood vessels. And that is where you end up with all the organ damage that you see with diabetes. Because remember, diabetes is the same three columns of disease, which is high insulin, high glucose, and high inflammation throughout the body. And this is why that's what's tearing up your blood vessels. It is not the cholesterol itself. So the big question right now that we're trying to ask is cholesterol dangerous? First, no. Why do they tell you that HDL cholesterol is good cholesterol and LDL cholesterol is bad cholesterol when it's the exact same cholesterol? The HDL and the LDLs, those are just fat mobiles. Those are just the carrier ships that are carrying this around. It's the cholesterol inside that they're talking about, and it's exact same cholesterol. The other thing I want you to realize, cholesterol is so vital to our existence, so vital that every single cell in our body has two different ways of getting the cholesterol that it needs. Every single cell in our body makes cholesterol because cholesterol is vital to the cell's existence, which means it's vital to our existence because that's what we're made out of, is all these cells. The way this happens is when your body needs to repair, when your cell, think of each individual cell, and this happens with every single cell in your body except red blood cells, because red blood cells don't have a nucleus, but every single other cell in your body needs cholesterol, but it needs other things also. And all the things that a cell needs in order to survive, to be able to replicate, to mend its outer membranes, everything that cell needs to live, those are called isoprenoids. These are things that the cell makes on their own called isoprenoids. And all these isoprenoids are what gives the cell its ability to grow, heal, thrive, and survive, be able to replicate. So the way it works is when your body needs some of these isoprenoids, and I'll tell you what the isoprenoids are in just a minute. When it needs something for it to be able to heal, grow, thrive, survive, replicate, it sends a signal to the nucleus of the cell saying, I need some isoprenoids. So the way this happens is when it needs that, this cell produces a little bitty protein called a reductase. Think of it like a little Lego building block, okay, or a big Lego building block. So what happens is the cell says, I need some isoprenoids in order to survive. So it starts producing this reductase. This reductase comes in contact with HMG-CoA. Remember, we started this off saying that HMG-CoA, the 3-hydroxy 3-methylglutarate coenzyme A, that comes from food. So when you eat food, our body turns in this HMG-CoA and it takes it in the cell and it binds to this reductase that the cell just made. When that food, that HMG-CoA, binds to that reductase, it produces a substance called mevalonate. Mevalonate and isoprenoids are the two big terms that you need to know. But mevalonate is what makes all those isoprenoids. So your body needs these things to survive. So these isoprenoids, so it produces reductase. You eat food and the food comes down and it binds to that reductase, that little Lego building block. A chemical reaction occurs and mevalonate is produced. Once mevalonate is produced, it makes all these other isoprenoids that the cell needs. So what are these other isoprenoids? One of them is vitamin K. So if you don't have any cells to make this vitamin K, you're not getting your vitamin K. And vitamin K is used for blood clotting, for bone health, prevention of blood vessel calcifications. It's good for wound healing, protection against certain cancers. Vitamin K is very important, and it's made from mevalonate. Another isoprenoid that's made from this mevalonate within the cell is coenzyme Q10. Coenzyme Q10, maybe you've heard of this, maybe you haven't, but this is something that they always tell you need to take when you're on a statin. The reason why is because coenzyme Q10 is an antioxidant. And we've already talked about an antioxidant is what eats up all these, binds up all these free radicals so you don't have all this oxidation going on all around your body. Coenzyme Q10 also is very vital in the production of ATP, which is your energy source for the body. It's also all the cell membrane support needs coenzyme Q10, so all your cell membranes are sturdy and healthy. It helps with cardiovascular health and multiple other biological roles. Now, another isoprenoid is called dolichols. Dolichols are things that help with the protein mobility, helps move protein in and out of the cell, helps make more proteins like the reductase, and it also helps stabilize the membranes. And this also are antioxidants. And then the other isoprenoid that the cell makes is called cholesterol. Cholesterol is just another isoprenoid that's made from mevalonate. Remember, and this is what's made from the reductase. So cholesterol is extremely vital. That's why every single cell in your body makes it. Every single cell in your body needs it. Cholesterol is used for hormone production. It's the basic building block for testosterone, estrogen, progesterone, all these sex hormones. It's also in the cell membrane of every single cell in your body. So it helps to firm up the cell membranes. It helps with the function of the cell membranes, including the nerve tissue, the membranes of the nerve tissue. So if you don't have enough cholesterol, then you're going to have problems with your nerves firing, including in your head, which means increased Alzheimer's, depression, all these other things that you see of the nervous system. Cholesterol also is the basic building block of vitamin D. And there's all kinds of information out about how important vitamin D is. It's used for so many functions in our body. Cholesterol also makes the bile acids, which is stored in our gallbladder, and that's what actually breaks down all the food that we eat. If you don't have enough bile acids or your gallbladder isn't working right, you're not able to break down all the food in your intestines, and that's why you have so many of these intestinal issues that you have when you have bile acid problems or gallbladder problems. And then also cholesterol, they've also found these LDLs are also, they help with immunity. They are anti-infectives. They can take care of bacteria and viruses that get into your blood. So cholesterol is extremely important. Since all this is so important, The cell, like I said, the cell has two ways of getting it. It makes it through the mevalonate process, where it takes the mevalonate and then starts making all these isoprenoids. The other way that your cells get the cholesterol that it needs, if it needs more than that, like more than it can produce, say like with the steroid hormones, testosterone, estrogen, progesterone, your cells will make the cholesterol enough for the cell to live, but it also needs to get cholesterol from the outside so it can make some of the other things because it can't produce enough. So if a cell needs more cholesterol than it can make, it puts more little LDL receptors all around the outside so it can attach to those little LDLs, remember the little fat mobiles, and pull the cholesterol out of it to go inside the cell. And that's so it can continue on with this function. Now, before I go further, I just want to make sure also that if you actually have a goal where you're wanting to lose weight, get rid of your pain and inflammation, or actually just get off a lot of your medications, we have programs to help you do this. We have one-on-one programs where we can talk to each other. We have digital courses that you can work through on your own. And we have some digital courses where you can do both. You can work them on your own, and then you also get us one-on-one throughout that. So if you want any help with this, all you have to do is click the link below and get in our free 15-minute wellness solutions chat. This isn't when we talk about your labs or your medications or reversing disease states. This is strictly to see if any of our programs can help you do that. Just click on the link below and get on our calendar, and we'll make sure that we can do everything we can to get you off medications, lose your weight, reverse your type 2 diabetes, and whatever else we need to do. How do statins work? Remember I said that when your cell needs some isoprenoids, the first thing it does is it starts producing this protein called reductase. That's that little Lego building block. From that reductase, it makes mevalonate. From mevalonate, it makes all the isoprenoids we just talked about. What statins do is statins come in and they bind to that reductase, that HMG-CoA reductase. That's why statins are called HMG-CoA reductase inhibitors. Once that statin comes on and blocks that little Lego building block, that reductase, that means it doesn't work. The reductase doesn't work anymore. So now your body can't produce any mevalonate. If it can't produce mevalonate, it can't produce any of those isoprenoids that I was just telling you about. So what happens is you've got this cell, it needs the isoprenoids. So it says, okay, I need some isoprenoids. So it puts out this reductase. But all of a sudden it finds out it still isn't getting any isoprenoids. So what your body does is it starts producing more reductase. And they've seen that people are on statins, the reductase levels are extremely high. So the cell thinks it doesn't have its isoprenoids because it doesn't have enough reductase. So that's why it makes more reductase. The other thing it does is it starts putting more of these LDL receptors all around the outside of it. So as this fat mobiles, these LDLs come through, it can pull the cholesterol out of that LDL and use that. So now think about what's going on. You have this cell, it's sitting there and it needs all its isoprenoids. So it produces reductase. Nothing happens. It doesn't get its isoprenoids. So it produces more reductase and puts LDLs around the outside. So now that it pushes the LDL receptors around the outside, that's pulling your blood LDL levels down. Okay. And that's what the drug companies are teaching the physicians. That's good. I'm saying that's bad. So what happened? You bring the LDL in, the cells. Now I have my cholesterol, but I don't have my vitamin K. I don't have my vitamin D. I don't have my cholesterol. I don't have the dolichols. I don't have my coenzyme Q10. So what happens is that cell dies. Okay. It got its cholesterol. So if you're looking at the blood, yeah, your LDL levels are going down, but they're going down because your cells are taking the last ditch effort to try to survive. And the statin has blocked that. So now it can't. So that cell dies because it doesn't have any of its other isoprenoids. And that's where the problem is. And that's why you see that statins have well over 70 different harmful effects. They take care of one thing, lowering your LDLs, whether that's good or bad, that's bad. And it harms all these other things in your body. These over 70 different harmful effects from these. So what are the good effects of statins? There are none. You are tearing up your body's ability to heal itself cell by cell. The only thing that statins are good for is making money. And that's why these drug companies make over $30 billion a year just on selling statins, trying to educate the doctors that every single person needs to be on a statin. And that is not true. What is true? What do you need to look for? The problem that we're looking for, we aren't clumping all the LDLs together, remember, because there's good LDLs and there's these bad small dense LDLs. And remember, the bad small dense LDLs, that comes from being made because you're eating too much glucose, too much fructose, and you're making these VLDLs, these big fat mobiles that are coming out of the liver. They have way more triglycerides than they do cholesterol, and that's how you make them. So the way you can tell when you get cholesterol panel, do not even look at the LDL level. That's the only thing your physician's going to look at is the LDL level. And this is not their fault. They don't know this. I've been a doctor of pharmacy for over 35 years, and I did not know this because we are all trained from the drug companies without the realization that drug companies are a business and try to make money for their shareholders. So the way you can tell if you have these small dense LDLs or the large buoyant is when you get your cholesterol panel, what you need to look at is your triglyceride level, your HDL level, and your total cholesterol level. Then what you want to do is divide your triglycerides divided by your HDLs. That's your good cholesterol. If that number is greater than 2, that's indicative that you have a lot of these small, dense LDLs that are causing all this blood vessel damage. What you want is you want your triglycerides to be no more than twice your HDL number. And really, you'd like that closer to 1-to-1. And some people, like my wife and I, their HDLs are going to be higher than the triglyceride. That's really what you want. So take your triglyceride divided by your HDLs, and you want that less than 2 and preferably closer to 1. The other thing you do is take your total cholesterol, divide that by your HDLs, and that number should be 5 or less, and really preferably less than 3.5. So if you look at your triglycerides, HDLs, and total cholesterol, your triglycerides divided by HDLs are less than 2, closer to 1, and your total cholesterol divided by your HDLs is less than 5, closer to 3.5. That is good. That means you have your LDLs are the large buoyant LDLs. Okay. If you have more of these small, dense LDLs, what you need to do is decrease your triglycerides and increase your HDLs. The way your triglycerides are elevated is because you eat too much glucose and too much fructose, which means you're eating way too much of this laboratory-made food and maybe too many of the fruits and vegetables. It's possible. And that's something we could talk about on your talk if you want to work with us. But that's what's happening is we're making all these triglycerides. So in order to lower your triglycerides, stop eating glucose, okay? Which means stop eating carbohydrates, which means stop eating laboratory food, and be very cautious on God-made food, on the real fruits and vegetables. And when you do have them, eat them. Do not drink them. When you drink your fruits and vegetables, you totally wipe out anything that might possibly be good from doing that. And you get nothing but a lot of fructose and a lot of glucose. The other thing is, how do you increase the HDLs? The only thing that's ever been shown to increase HDLs is eating fat and cholesterol, because HDLs are made in the intestines. Your VLDLs are made in the liver, and as they get out in the bloodstream, they get converted into the IDLs and LDLs. But your HDLs, your good cholesterol, are made in your intestines, and that has mostly cholesterol and just a little bit of triglycerides. And again, that comes from you eating it. And also they found that lifting heavy things also can increase your HDLs. So for your triglycerides to be lowered, decrease your fructose and your glucose. To raise your HDLs, increase the amount of good, healthy fat that you eat, which is animal fat, which is lard, which is pork fat, tallow, which is beef fat, fruit oils like extra virgin olive oil, coconut oil, and avocado oil. Those are good. All these seed oils, these vegetable oils that line your grocery store shelves, stay far away from those. Your safflower, soybean oil, sunflower oil, canola oil, Crisco, all those, stay far away from those because those just cause inflammation in your body. That's what statins are. That's how statins work. That's how statins lower your blood LDL. And that's why that's not necessarily a good thing. In fact, I would argue that is a bad thing. I know there's a lot of information. I didn't want to throw a bunch of words out there, but there are things that you need to know. And so I hope this helps. Until next time, thank you so much for listening. Stay nourished and stay well.